Here's everything you need to know about polynomials before your A-level Maths P3 exams. Polynomials are basically just expressions that contain multiple powers of a variable. So for example, here we have a variable x in this expression, and this expression contains multiple powers of this variable, such as x to the fourth, x to the second, which is basically x squared, and also x to the zero, because as we know that any variable or constant which is raised to the power of zero is just one, so it just becomes one and it's multiplied by this five. And basically, that's how we know that this expression is a polynomial. Now, in our exams, these polynomials are usually denoted using the symbol of px, which is basically similar to what we learned in functions, where an expression is denoted using f of x. However, here, because we are dealing with polynomials, the f is replaced by a p, so it's basically p of x, where p is for polynomials. And we can actually solve this by inserting different values for x. So for example, if here we had p1, p1, then that would just be equal to 2, bracket 1 raised to the power of 2 plus 6 times 1 plus 1. And now we can just solve it, and this should be, and this is equal to 9. And this basically just works like functions themselves, where you insert different values for the variable inside of these brackets, and they return different values. However, this is not our main workings for this chapter. Our first major working for polynomials is actually long division. Now, when we're asked to divide a polynomial by either a linear or any other type of expression, it can even be divided by another polynomial, then we have to use a method called long division, especially if we are asked to find the quotient of the division. Because later on in the chapter, we will learn some theorems, the remainder and the factum theorems, that will allow us to find the remainder easier. However, if we are asked to find the quotient, then we have to take the method of long division. Now, to start long division, we're just going to set up our expressions like this, which is basically how we use normal long division. Is basically just put the dividend inside of this shape and then put the divisor outside. And now what we're going to do is, first of all, we're going to fill in all the missing powers. So for example, you can see that we jump straight from x to the power of 4 to the power of 2. There is no power of 3 in between, and also no power of 1, which is basically just going to be x itself. So what we're going to do is we're going to fill in those powers. So the way we do that is just we're going to add a coefficient of 0 next to the powers, which will basically mean that those powers basically aren't really there, but we have to add them here to make our long division easier. So we're just going to add a 0 to x cube and then a 0x, just like this. We are just going to fill in all the missing powers, and you have to do that before starting any long division. Now that we have filled in our missing powers, we just need to start the division. And the way we do that is by first finding out the quotient that we multiply this expression with. And to do that, we just need to divide this inner first term right here, 2x to the fourth, by this first term right here, which is just x right here, which is basically the rule that we are going to follow throughout our long division. Basically, after adding every quotient, we're just going to find the next quotient using this method again, because the inner first term is constantly going to keep changing. So basically, we can find it by just writing this expression. So q, which is basically quotient, is going to be equal to, like we just add a fraction right here, is just going to be 2x to the fourth, and it's going to be 2x to the fourth divided by x, which is just going to give us, no, which is just going to give us 2x to the cube, because we have removed one power of x from 2x to the fourth, so it's just going to be 2x cubed. Now that we have the quotient, we're first of all going to place it on top of this shape right here, on top of the division shape right here. So 2x to the cube, cube right here. We're just going to add this right here, and we're going to keep adding our quotients to this value right here. And now what we're going to do is that now that we have the quotient, like in normal division, we're just going to multiply our quotient with our expression right here. So we're just going to do 2x to the cubed times x minus 3. And that is going to give us 2x to the fourth minus 6x cubed. And basically that is going to be the value that we're going to subtract from here. So now what we're going to do is I'm just going to copy this right here, and we're just going to write this down right here. So if we ever, and now I'm going to enter. Now I'm just going to paste this value right here, going to move it a bit back. Oh, so now that we have the value that we're going to place here, what we're going to do is with that we're going to subtract this entire value from the initial expression right here. And as you guys can see, this first term is actually equal to this value right here. So when we subtract this value from this initial value, these both are going to get cancelled out, and basically we're just going to left with 0 right here. And now as you guys can see, we initially had this as 0x cubed. However, now since this is minus, however, we're subtracting the entire value, which basically means we're multiplying this entire expression by -1, or just a minus. This will actually be added to this value. And so now what we're going to be left with is just going to be, we're going to be left with 0x to the fourth here, so we can ignore that since we have subtracted 2x to the fourth from 2x to the fourth. So what we're going to be left with is 6x to the cube minus 6x squared plus 0x plus 5. Now, as you guys can see, our inner first term has changed to 6x cubed. And now we can use this rule again to find our next quotient. So what we're going to do is we're going to divide 6x cubed, 6x third by x, because x is still the outer first term. And we're going to be left with 6x squared. As you guys can see right here, since we have removed one power of x from the top, we are just going to be left with 6x squared. So now we're just going to multiply our divisor by our new quotient. So it's just going to be 6x squared. And we're going to be left with 6x cubed minus 18x squared. And this is our new value that we're going to be subtracting from right here. And as you guys may be able to see that again, this term right here is equal to this term right here. And when we subtract both of these values, both of these are going to get cancelled as well. Okay, now I forgot to add this quotient right here. So make sure that you always remember that every time you calculate a new quotient, you always first put it right here and then you multiply it by our divisor. And now that we have gotten our new value, I have placed it right here. Now we're going to subtract it. So this 6x cubed and this 6x cubed are just going to get cancelled. However, this minus 18x squared is getting multiplied by this minus as well. So what we're going to actually do is just add this 18x squared to this minus 6x squared. This is just basic algebra. However, we need to be careful with these workings, because sometimes when we are asked to find variables in our polynomials, this can actually backfire if we made a silly mistake in our signs. And so we need to be very careful with our working in signs so that we can actually calculate the correct variable. Now, as you guys can see, after carefully subtracting, we see that this 6x cubed and this 6x cubed are get cancelled, and because this minus 18x squared is getting multiplied by this minus, we're basically just going to add it to our upper value, which is minus 6x squared. So we're just going to get 12x squared, and then we're just going to take all the other values down with unchanged. And now that we have uh, again gotten a value, we are going to use our rule again to find the next quotient. So here the new inner first term is 12x squared, while our outer term first term remains the same, x, and we're just going to basically write this down right here, 12x squared divided by x, and it's just going to give us 12x because we remove one power from there. So this is a new quotient. So first of all, we're going to add it right here. So plus 12x. And now what we're going to do is we're going to multiply our expression itself. So 12x. And this is going to give us 12x squared minus 36x. And now what we're going to do is we're going to take this value again and we're going to subtract it from right here. As you guys can see once again that this term right here is equal to this term right here. So again, both of these are going to get cancelled. This is basically why we use this rule in the first term divided by outer first term to find the quotient, because it always gives us the correct power and the correct variable and the correct constant, so that we can keep cancelling out these variable terms to easily find out our remainder. So here once again you can see we're going to subtract 12x squared from 12x squared, and it's just going to cancel out these terms. And because this minus 36x is getting multiplied by this minus, what we're going to do is we're just going to add it to the upper value right here, and it's just going to be 36x. So as you can see right here, this 12x squared and this 12x squared get cancelled out, and we add the 36x because this minus is getting multiplied by this minus, so we're just going to add it to the upper value. And now this 5 constant comes down as it is. So now we have another new inner first term, and we're just going to divide it again. So we're just going to divide 36x by x, and it's just going to give us 36. Now we're going to multiply 36 by this, but first we have to actually add it right here as we remembered. So plus 36 right here, and now that now we're going to multiply our divisor by 36, and it's going to give us 36x minus 108. And as you guys can see, again, this term is equal to this term, so these are going to get cancelled out again. So we're just going to minus 36x minus 108. Now we're going to place it a bit like this. So as you guys can see, we're going to subtract 36x from 36x. It's going to get cancelled. This minus is getting multiplied by this minus, so it will actually be added to this 5 right here. So at the end of our division, we are going to get, since there are no variables left and only constants left, we are going to get, so when we add, when we add 108 to 5, we are just going to get 113. And this right here is our remainder. So now we have successfully used long division to calculate the remainder, and this whole upper portion right here is the quotient. So I know it's a long working, but it's actually pretty easy. We're just going to follow the same rule after successfully subtracting each new value from our initial values. Now, another thing to note is that you stop long division when the power of the variable of the inner value is less than the power of the variable of the divisor itself. So here, the remainder, basically here, the power is equal to the power of the divisor. So we're going to divide again. However, here the power of x is 0, which basically means it's 1. So it's getting multiplied by the constant. And here the power of x is 1. So it is a greater power in the divisor than there is inside of the dividend. So we know that is where we're going to stop our long division. Now the next part of our polynomials chapter is the remainder theorem. So here we have the same expression that we used in long division being divided by the same expression again. But what we can actually do is use the remainder theorem to find the remainder of this division. And what the remainder theorem actually is that if p to the x is divided by a linear divisor, then put the divisor equal to 0 and make x subject and use that value of x to find, oh wait, it's going wrong way, to find the remainder. Now what I mean by that is that if we have a linear divisor, so for example here this is a linear expression, x has only one power, so what we can actually do is put x minus 3 equals to 0 and then make x the subject. So x is just going to be 3. And now what we can actually do is that we can substitute this value of x right here, and we're just going to get the remainder of this division. So if I put right here, so p, and then as x is 3, we're just going to put 3 right here. We're going to put 3 right here, and that is just going to be equal to 2, and then we're going to do 3 raised to the power 4 minus 6, 3 raised to the second power plus 5. And what that is actually equal to is that this is equal to 113, which was the remainder of our long division, as you guys can see right here. This was 113 remainder, and if you actually calculate this value right here, it comes out as 113. Now, what you may be thinking is that why should we use the method of long division when we have such a shorter working right here, which is allowed in the exam? Well, there is a general rule right here that we can only use the remainder theorem if the divisor is linear. So we can only use long division when our divisor basically only has one power of x, which is basically it can be x, just x itself. So basically we are just going to get one value of x right here. if we have, say, x raised to the second power, so x squared minus 3, and that was our divisor, we would actually have a lot more trouble finding one exact value for x. So we can only use this theorem to find the remainder if the divisor itself is linear, and then we can just make x the subject and then we'll substitute that in our expression that we had to divide, and we're just going to get the remainder. Another thing is that we have to use long division if we need to find the quotient. If the question requires the quotient, we have to use long division, since only that will give us the quotient right here. The remainder theorem only gives us the remainder itself, which we may be able to use to prove that the remainder is true. We can basically just use it sometimes to check our answers if our remainder is correct and we had to divide using a linear divisor. Now, the last thing we have to know in this chapter is the factor theorem, which basically means that if a polynomial is divided by a factor of itself, basically what that means is that if x minus a is a factor of this polynomial x, as we know that the polynomials can be denoted by this, then if using the remainder theorem, x will be a, and if we substitute that value of x as a, then the remainder of this division is always going to be equal to 0. Now, what do I mean by that? Basically, if we divide a number by its factor, we are always going to get 0 as the remainder. If you divide 4 by 2, then you know that 2 times 2 is 4, so we're just going to minus that, and the remainder is going to be 0 itself. So this is just another theorem that we need to know, since it is usually used to find unknown variables in our polynomial itself. And it's a very important factor and very important theorem that we have to know. Now here we have an example question where this polynomial, which is denoted by px, is 2x cubed minus ax plus 3, and it has a factor of x minus 2, and we are required to find a. Now, as the factor is linear, which is basically the divisor, and it is linear, which means that it has one power of x, and it only has x raised to the first power, and there is no square, so it is a linear expression and not a quadratic or a cubic. We can use the remainder theorem and equate all this whole equation equal to 0. Since this is a factor, the remainder will be 0. So here, what we're going to do is we're going to, since x minus 2, and we're going to put that equal to 0, so, and make x the subject, so x is just going to be 2. So we're just going to write p and then substitute the value of x as 2 equals to 2, and then 2 cubed minus, and then since a is a variable and x is just going to be 2 itself, 2a plus 3, and what we're going to do is we're going to equate it to 0, since the remainder of this is just going to be 0. And now what we can do is we can just solve for a. So 16, since 2 cubed is 8 times 2 is 16, and then we're just going to add 3 minus 2a is equals to 0. Since both of these are constants, both of these are numbers, we can just add them together while a is a variable. So now now we know that 19 plus 2a is equals to 0. Sorry, 19 minus 2a is equals to 0. And now what we're going to do is we're just going to bring 2a to the other side by adding it to both sides. So we're just going to get 19 is equals to 2a, and we're just going to solve for a. So we're just going to get a is equals to, and we're going to get a fraction 19 by 2, which is just going to be 9 and 1 by 2. And there we go. That is our value for a. So basically, this is basically what the remainder factor theorem and remainder theorems are used for. They are used for solving these equations and finding values of unknown variables. If our divisor or factor is not linear and is a quadratic or a cubic expression, we have to use long division, which is why this was the first thing that I explain, because this is what we're going to be using the most in our polynomial questions. These theorems are basically just used to verify our answers, or in smaller questions where we have to find the value of unknowns. Another thing to note is that if we are given a polynomial and we use long division to find the remainder and quotient, and if the divisor is a factor, then obviously the remainder is going to be 0. However, the quotient is going to be the other factor of our of the divisor of the actually the dividend itself. So if we are basically dividing say a polynomial by a divisor, and both of them are non-linear. Basically, the divisor may have a power of 2 with x to the power of 2 or 3, then we can actually use long division to find the other factor of the dividend. And basically, and then we can just, it actually used to factorize equation themselves. So basically, like, if you are asked to completely factorize a a polynomial and we're given one factor, then we can find another factor and then completely factorize that expression. And so basically, the question asked us to completely factorize a polynomial, then we're obviously going to need the quotient. Sorry, the quotient. We're going to need the quotient, since that is going to be the other factor of the polynomial that we're dividing, and the divisor is one factor of the polynomial. And so after getting our quotient, which is going to be the factor, and our divisor, which is going to be one factor for both of these factors, we can then also factorize them further into the simplest forms, and that is when we're going to have a completely factorized polynomial. And now we're done with the entire polynomial section of our P3, and now we have covered all the important workings and all the theorems that we need to know. Now that we are done with the concept, we should go master it through past paper practice. And with that, Calquix out. Now you should go ahead and try out this question yourself. And if you found this video helpful, make sure to subscribe so that you don't miss the next content of chapter. And yeah, I will see you in the next one.